Before we dive into the meat of this course, let's do a quick overview of what's in it so you know what to expect and what not to expect, and maybe the sections you might be able to skip. We'll start with a crash course in the Python programming language, and this is not going to just be about Python, it's also about Matplotlib and Pandas and Seaborn, the visualization and data processing libraries we use in the field of machine learning and data science. Now, if you're already familiar with Python and data science, you can probably get away with skipping that section. That's totally fine. It's just there so that this course can be used by people with a wider range of experiences. If you already know how to use Python and Anaconda and Seaborn and Matplotlib and Pandas and scikit-learn, go ahead and skip that section. You'll be fine. You can dive then right into the computer vision sections of this course. That's where Ryan's going to take over and really get into depth on how computer vision works with a lot of fascinating hands-on examples. He'll walk you through how to detect lane lines, how convolution works with sharpening and blurring, how to do edge detection, image transformation to make sure that images all line up together properly, how to mask off regions of interest in an image, how Ho transform theory works. That's actually a feature extraction technique for trying to find objects in your images. You'll have an exercise of doing real-time lane line detection using real video streams. That's going to be a lot of fun. He'll cover template matching, which is another way of recognizing objects in images, how corner detection works, image pyramiding, and several feature matching algorithms for actually identifying the stuff in your images like street signs, including SIFT, SURF, FAST, and ORB, and also a histogram of oriented gradients, which is called HOG for short. He'll also cover camera calibration and distortion correction, and again, there'll be a lot of hands-on examples so you can see this stuff in action and play around with it yourself. I'll then take control back. We'll talk about machine learning during my section of the course, and that's going to cover two different sections. We'll talk about train test and cross-validation, linear and logistic regression, decision trees, naive Bayes, and support vector machines. Now, if you've taken Sundog Education's course on data science, machine learning, and deep learning with Python, you're probably already familiar with a lot of this material. We did re-record it and give it more of a spin on self-driving cars, but if you have taken that material before, you can just breeze through that section and you'll understand what's going on very quickly. It's a good refresher, though. We'll then dive into the world of artificial neural networks and how they apply to self-driving cars. We'll start with the basics on how a perceptron and multi-layer perceptron works, how the activation and error functions in neural networks work, how gradient descent is used to train these networks, and backpropagation as well. I'll then dive into deep learning with you, show you how to use TensorFlow and the Keras API. We'll learn how to optimize your deep learning networks with dropout regularization. And then we'll finally get into applying deep learning to self-driving cars through convolutional neural networks, which can be used to identify objects in video streams or images very effectively. We'll have a hands-on example that we'll wrap up with using a specific kind of convolutional neural network called Linnet, and you will actually use that to classify traffic signs in real images from real cars using a real neural network on your own GPU. So, fun stuff. Let's dive in and get started.